Welcome to the channel. This is episode 5 of a May 2021 IB Diploma Mainstream Science Multiple Choice Attempt series. I'm going to do the Physics Time Zone 1 multiple choice paper in this video, hoping to make it highly educational. Because physics is just way more challenging than, it's just really challenging in general. Definitely way more challenging than chemistry and biology. And a lot of students typically run out of time during a multiple choice paper, and that's why the grade boundaries are so low over the years. Common bad practices include students thinking the formula book contains the answer to everything. Physics is not just about plugging numbers into formulas regrettably. There are a lot of times when you have to know where to add or subtract quantities like energy, like add and subtract forces vectorially. Or sometimes you have to equate quantities like equate force. Sometimes you have to take ratios. Sometimes you have to ditch the equation and rather go for a graphical approach instead. So these are skills that you have to acquire during the course. And of course, there are students who just don't know the equations well enough, period. If you have to look up the formula book for the Soviet equations when you're walking into the exam, then I have to say that you have issues. Another common mistake, or another common practice that students try to use is to rule out the wrong answers. Especially in particular when the question actually requires you to solve the problem analytically using proper equations. Ruling out the wrong answer is number one, for not very reliable, and number two, it's very time consuming. So anyways, I'm about to begin. So this video represents a genuine attempt, as I want to not just, well, as a teacher, I want to revise and challenge myself. But also I want to provide a realistic simulation of exam conditions, in the process demonstrating some proper and efficient techniques in dealing with different types of multiple choice questions. So let's jump into the paper. So this is my Excel spreadsheet, which I use to record my answers. And the snipping tool for doing work. Okay, question 1, 2 sets of data shown below with circles and squares are obtained in 2 experiments. The size of the error bars is the same for all points. And let's see the question. What's correct about the absolute uncertainty and the fractional uncertainty of the y-intercept of the 2 lines? The absolute uncertainty should be the same, because what you need to do in general is to add a steep line and add a gentle line. Probably works better if I have paint which allows me to draw a straight line. But this is the standard thing that you have to do when you want to estimate the y-intercept. So this will be the range of the data. And if all the error bars are the same length, then the range of the max and min values of each y-intercept should, well, the error bar for each y-intercept should be the same, but of course, if the y-intercept value is larger, then the fractional uncertainty will be smaller. So the fractional uncertainty will be larger for squares because the squares, the line from the squares has a smaller y-intercept value, but same absolute uncertainty. So answer should be B. Second question, let's see. A large stone is dropped from a tall building. What's correct about the speed of the stone after 1 second? The speed should be, well, should be 10, using just v equals to u plus at. That's not what they're asking. But that's actually not a Soviet situation, because as predicted by Soviet predicts constant acceleration. So the speed should be increasing at a constant rate. But clearly they want you to consider the effects of air resistance, which causes the speed to increase at the decreasing rate, because the air resistance starts to gradually increase itself as the object itself picks up speed. So these, again, the answer. Okay, question 3, let me make it bigger. The graph shows the position of an object varies, how the position varies with time within a 3-second interval. At which point does the instantaneous speed of the object equal to the average speed over the interval? Interesting. This is for math students. This is actually the application of the mean value theorem. So what even is a mean value theorem? Well, the mean value theorem says that if you have a continuous graph, then there will be a point somewhere on the curve whose derivative, so whose gradient, I think the answer should be C here. The gradient at that particular point equals to the gradient of a line segment that connects the starting and the end point. So the instantaneous speed requires you to evaluate the value of the gradient at that particular point. So clearly C is the answer. Question 4, a car takes 20 minutes to climb a hill at a constant speed. Mass is given, then car gains gravitational potential energy at a given rate. Take the acceleration of gravity to be net. What's the height of the hill? That's a weird question for sure. I think in this case, they want you to recognize at constant speed. So this is an energy conservation situation. So the car engine provides energy. The car engine energy, or the fuel energy, becomes a combination of kinetic potential and also energy wasted due to resistive forces. But then resistive forces are not really mentioned in here. And also the fact that the car maintains a constant speed means that we can ignore any change in K. Even the K itself is not zero, but then the change in K is zero. So GP power equals to engine power. And the engine power is going to be this anyways. Or is that the engine power? But that may not be the engine power, but then they just tell you GP power. So mg, but GP power will be GP E divided by time equals to 6,000, I'm guessing. So 1200 times 10 times the height which they're looking for, divided by 20 minutes. So of course you have to convert units. I'll cancel a whole bunch of zeros. I'll cancel the 12 with 2, so get a 6. So 6 times 10 times height equals to 6,000. And I don't think the answer is here. Well, actually, no, I'm still, because I overlooked the 6. Okay. So 10 H equals to 6,000, so H equals to 600. Question 5, a mass is released from the top of a smooth ramp up height H. After leaving the ramp, the mass slides on the rough surface. The mass comes to rest in the distance D. What's the coefficient of dynamic friction? Interesting, let's figure it out. So this is a two-stage energy conservation problem. And so during the fall, with sliding down a smooth ramp, so there's a situation where the kinetic energy at the bottom equals to mgh. Like energy stored at first, at the top, and then the kinetic energy all becomes, well, he lost to the surrounding because that's what friction does. So you also have half mv squared transfer to energy to the surroundings as a result of friction acting on the system. So you can just write mgh equals to fd. The coefficient of dynamic friction comes in play because friction equals to mu r, r being the reaction force, which is the support force. The reaction force on horizontal ground is just mg. And you can see mg's cancel, so coefficient of dynamic friction just equals to h over d. Question 6, masses x and y rest on a smooth horizontal surface and are connected by a master spring. The mass ratio is, well, masses are 3 and 6. I'm not sure whether you need to use actual masses or you need to use ratio, but I feel like you may need to use some actual mass values. The masses are pushed together towards each other until the elastic potential energy stored is 1 joule, and then the masses are released. Well, this is hard. This is really hard. I've never seen anything like this before, but I think I know how to solve it. Because you have 1 joule, which is half kx squared. I don't think you need to use a k. 1 joule equal to half 3 Vx squared plus half 6 Vy squared, according to energy conservation. because you achieve the maximum speed when the spring is neither stretched or compressed relative to its actual length. What you also need to invoke in this case is conservation of momentum, because the two masses have the same momentum. So this is actually not ideal. You should be using the p squared over 2m, I think. So you've got p squared over 2m twice. Agreed? I think you guys do. Okay, and then you can see, you don't quite know the momentums yet, but you can see that the kinetic energy is inversely proportional to the mass. And the mass ratio is 1 to 2, which means that the little guy should have twice the kinetic energy as the big guy. Yeah, so in the case where Ke equals to, in the case Ke is inversely proportional to m, or more like when momentum is constant. And momentum is constant because of this is an isolated system. X and Y will just possess momentum of equal magnitude but different direction at all times. So I think you can claim the mass X anyways will have 0.66 joules, well 67 I guess, 67 maybe, and the mass Y would have 0.333. So that's 1/3 of a joule. And I think, so that's, once you figure out how the energy is distributed, you can use half mv squared. And if you continue crunching the numbers, half, 1/3 equals to 3v squared, 1/9 equal to v squared, so v equals 1/3. Well, that's a tough question. That's a very tough question. I think we got this. 7. A force acts on an object of mass 40 kg. The graph shows how the acceleration changes with distance. The work done by the force is the area under a force time. No, area under a force distance graph. This is not a force distance graph, but then acceleration. If we just multiply the acceleration axis values by the mass, which is 40, then that becomes a force, and you're just estimating the. So all we need to do here is to determine the area of this region and then multiply by the mass of the object, which is 40. Composite area, I'll just kind of like this maybe. So the bottom is 40, and at the top, there's an ugly arrow. Is half times 2, because 4 minus 2 is 2, and then 20 minus 10 is 10. That's 10. So the area is 50, and then you can just multiply it by 40, so to get 2000. As the number of joules delivered to the object as a result of this accelerating force acting on it. 8, what aspect of thermal physics? Okay, nature of science question. Best explained by the molecular kinetic model. So let's figure out the equation of states of the ideal gases. I think that's the answer, because the rest, Celsius and Kelvin temperature, is also developed experimentally. So they had to do VT and PT experiments to work out the temperature axis intercept, and then that's how they figure out negative 273, like experimentally. But I think A is more fundamental, because molecular kinetic model can explain the pressure and the volume and then the temperature of gases in terms of particle behavior, and then they can further relate, at least qualitatively, like for example, how heating a gas causes its pressure to build up. I don't think C and D have anything to do with the molecular kinetic model. I'm pretty sure it's A, but then I'll still mark. Yes. Suspicious question. Okay, moving on to question 9. When 40 kilojoules of energy is transferred to a quantity of a liquid substance, the temperature increases by 20 K. you supply more energy, 600 kilojoules, supplied to the object already at its boiling temperature, and it just completely boils. So let's figure this out using equations. They're asking for the ratio of C and L. L and C, my friend. So you have Q equals to ML versus Q equals to MC delta T. I'll just write the quantities in a more properly formatted equations. I'll just write Q1 and Q2 for the two amounts of heat. So 600, the kilo will cancel over 40 equals to M, which is not given, but you can see that M should be on the verge of cancellation. Temperature change is just 20, and if you just clean up everything, the L to C ratio is, just write this out, 20 times 600 divided by 40. So that's 300. Unit is annoying. Oh, why you do this to me? Okay. Joule per kg for this guy. C is joules per kg. Well, it can be gram or kilogram at least, as long as the metric multipliers are consistent. But then there's a per temperature unit for the specific heat capacity. So divide by K minus 1, meaning it should be this. So question 9. Question 10, two ideal gases X and Y at the same temperature. Mass of one particle of gas X is larger than mass of one particle of gas Y. So what's correct about the average kinetic energy? So same temperature means same average KE, and the K is half mv squared. So if K is the same, the heavier gas particles will have a lower average speed. So X is heavier, therefore X should be slower. So choice B. Moving on, question 11, waves. Well, SHM shows a VT graph, and they want you to find the combination of XT graph. So for competent math students, you can just use differentiation and integration. Actually, I don't even need to draw this. If VT is a cosine graph, then AT should be negative sign because the derivative of cosine is negative sign. And then XT should be sine. So choice A looks like the correct pair. So A. Question 12, a sound wave has a frequency of that and a wavelength of that. What's the distance traveled by the sound in 2 milliseconds? So what student needs to know is that, well, the distance traveled by the wave it's just a speed multiplied by the time. So you can figure out the speed of the wave by just doing frequency times wavelength first. So speed equals to 1000, because that's one kilohertz times 0.33. That's 330 meters per second, quite typical for sound waves. And what you need to do is to do 300 meters per second times the actual time. So the wavelength is not the same as the distance travel. The wavelength is the distance travel over one period. In this case, it's just 330 times 2, but that's millisecond, but then they don't really have a choice that traps you for not recognizing the milli. So it's just going to be these two. Sound wave is longitudinal, and that's just common sense, unfortunately, that a lot of people don't have. But anyways, answer should be D. What is monochromatic light of wavelength lambda is incident on a double slit. The resulting indifference pattern is observed. And so double slit, I think you can just use a double slit equation. Double slit equation says that the separation of the fringes equals to lambda capital D over small d. And what is Y? Okay, so Y is basically capital D. So the separation is small d. And then lambda is lambda. So if we double lambda, double capital T, and double small d, then S should increase by, but S should change by a factor of, or 2 times 2 divided by 2 is still 2. So S should be doubled as well. So 110. A metal rod of length 45 is clamped at its midpoint. The speed of sound in the metal rod is that, and the speed of sound in air is that. The metal rod vibrates at its first harmonic. What's the wavelength in air of the sound wave produced by the rod? Well, let's figure out the wavelength in the metal first. The rod is clamped at its midpoint. Oh, that's important. Clamped at its midpoint meaning that it's still going to be like free end vibration. And that also means that you are modeling the rod as a double open end object. Because clamping at the middle means that you need to have a node in the middle in terms of vibration. If the metal is clamped at the end instead, then you would have the rod is basically like an open closed pipe. But anyways, you have to recognize that the wavelength, the length of the rod represents half the wavelength. Okay, so the length of the rod is 45, therefore the wavelength is 90. Which you need to convert into meters anyways. So if the wavelength is 0.9 meters, then you can figure out, well, they want you to find the wavelength of the sound in air. So this is a refraction situation as well, in addition to the standing wave phenomena. In a refraction event, the wavelength is directly proportional to the speed. Wavelength is directly proportional to speed during refraction because frequency stays constant during refraction. So speed equals to frequency times wavelength. And if frequency is constant, then speed is directly proportional to wavelength. So the sound is lower in air by a factor of 5. Therefore, the wavelength should also decrease by a factor of 5. Okay, okay, charges. Two charges, equal magnitude, separated by distance 3. What's the force and what's the field? So we just need to perform some calculations. And I think you actually need to punch numbers into KQQ over R squared and also KQ over R squared. So the force equals to K, and K is 9 times 10 to the negative 9. And I hope you guys know this in your head already by practicing enough. If not, then this quantity is available in the formula book. I think good students should also just remember some of the like physical constant values in your head as well. But I guess not everyone can achieve that status. But for me as a teacher, for sure, I know my formula book very well. But in any event, so this is KQQ over R squared for the force. I'll just use calculated notation. Don't overlook the nano. Again, I could have written that thing squared, but then squaring is not that as easy for calculation, for cancellation of like common factors within a fraction. The distance is about 3 meters. That's a long distance. And I actually made a mistake. The power of 10 is positive 9 and not negative 9 for Coulomb's constant. And I also made a mistake with the distance. I was looking for the 4 and I don't see the 4 yet, but then now that I fix everything. So that 9 and 3 squared cancel. 10 to the 9 and cancel with 1 of the 10 to the negative 9. So the force is definitely this much. The field due to Q1 at the position of Q2, you just use 1Q. And then you can even use F equals to EQ. So E, which is electric field, equals to F over Q. You can use KQ over R squared if you want to. The 4 times 10 to the negative 9 divided by the charge of the charged particle which generates the field, which is Q1. It makes no difference in this particular question, but in general, you have to divide by the charge of the particle that is generating the field. With the particles generate a field just because they exist. Either way, you divide by 2 times 10 to the negative 9. So I think the negative 9s cancel and the answer should be 8. It's 16 VI characteristic. Oh, this is interesting. When the conductors are placed in the circuit below, the ammeter reads 6. So when you have an ohmic conductor, which is what T is, and an S, which is non-ohmic because the VI graph is curved, they typically give this question in the long paper instead of multiple choice, but that's interesting. And what you need to do is to recognize how to process a graph. I'm not even going to look at the choices because the EMF is going to be like each conductor will experience the same EMF, but they will experience different current because they're in parallel. They don't need to have the same current, but they must experience the same EMF. And what you need to do is to just put a ruler, which I can't. I can, but I'll just eyeball it. 6 amps, which means that you need the two objects to experience the same current at a common voltage. But this is just a really easy version. If you look at November 2016, there's a much harder version of this. But here the common, you can just experience 3 amps each at a common EMF of 4. So the answer should be 4. The answer of 4 is somewhere. I need to make this smaller. I need to drag this away and then make this smaller. Okay, question 17. For a real cell in the circuit, the terminal PD is at its closest to the EMF. Okay, a lot of people just don't understand what terminal PD is. EMF is like the maximum possible voltage that a battery can supply to the external component, but depending on the operating circuit's current, the resistances of the material of the wires and also within the battery may end up using some of the voltage. If the internal resistance is much smaller than the load resistance, yeah, A looks correct. If you want to use an equation, E equals to V minus IR. It's an equation that you can derive from the formula book equation, which says E equals to I R plus R. They have something like this, I don't remember. I can check my notes, which I have compiled over the years. Because the formula book definitely does not give you the more useful equations. Actually, the formula book actually has this. If you expand it, then you actually more easily understand the terms. And but in any case, I need to minimize this, which is difficult to do if I'm sharing screen. I'll just have to open my Excel and open my browser and open my snipping tool. Nothing to do with C and D. It's just question 18. An electron enters the space inside the current carrying solenoid. Interesting. The velocity of the electron is parallel to the solenoid's axis. The electron will be subjected to a magnetic field due to the solenoid. The electron motion, however, is parallel to the magnetic field. And an electron running parallel to a magnetic field will experience nothing. You need the electron to have a velocity component that is perpendicular to the magnetic field in order for some magnetic force to be felt. Okay, question 19. As child stands on the horizontal rotating platform that is moving at a constant angular speed, the centrifugal force of the child is provided by, oh, definitely friction. Nothing else works for horizontal circle. Actually tension in the child muscles. Well, the upper body of the child. Yeah, if you watch some YouTube videos and you will see all of these people will try to like extend outwards, and that's because of the human body structure. Like in physics, we just typically deal with point masses. In reality, an object has dimensions, and the different parts of the object will experience different type of forces in order for the entire object to stay as one piece. And the upper body is typically like kept in circular motion by muscles inside an individual. But I don't think this question is sweating that kind of detail, so I just go for B. 20, okay, nuclear model now. Difference between adjacent energy levels are shown below. Smallest frequency. So what you have to do is to recognize that the possible transitions to get small frequencies are the result of low energy transitions, because energy is directly proportional to frequency. Energy of the photon equals to h f. I was about to write this because this is the Greek letter n, which is used as the frequency symbol for chemistry. Physics, we use f for some reason. Modern chemistry, they use this for some reason. I think f is more easily understandable for people with small brain. Anyways, h is, well, energy is low. It's going to be this one, and there's one larger transition. But then they want small frequency, so I'll just use the 6.63 and 13.3. And each of these need to be divided by Planck's constant, which is, well, not surprisingly, 6.63 times 10 to the negative 34. So this transition should be 1 times 10 to the 15. The second transition should just be 2 times 10 to the 15. So the answer is just C, yes. Question 21, what's the relationship between the value of the unified atomic mass unit in grams and the value of Avogadro's constant in mole? Interesting. Unified atomic mass unit. Wait, let's copy this. Could unified atomic mass unit is the mass of 1/12. It's 1.661 times 10 to the negative 7, which is 1/12 of the mass of a carbon-12 atom. The 12 is the molar mass as well, and then you can just do this. I think the answer is B, by the way, but I'm just working through this. Yeah, that's how they get. And 12 is actually in grams. In chemistry, they use grams. In physics, we use kg. But none of the choices involve the conversion factor of 1000 anyways. And if we have this times Avogadro's again, oh, but this is in grams, okay. So this is kg. I guess like if you don't remember the definitions of some of these terms, you can just look up the formula and get these two numbers and recognize that they multiply to become 1. Okay, question 22. In the hydrogen atom, the sum of the mass of the proton and the electron is larger than the mass of the atom. What interaction is mainly responsible for this difference? That's very weird. It's very weird because usually they want to mention belts. But why should they even be larger? It's inside the hydrogen atom, there's no neutrons typically, and there's no strong force. And the strong nuclear force, like, is the reason behind the mass defect. When protons and neutrons attract each other, there will be an observed decrease in mass. That's a mass defect. the sum of the masses of the proton and of an electron. But then the electron does not experience a strong force. The mass of the atom should comprise of the proton and the electron. So this is very confusing. I've never seen this before. I'm not sure whether a weak nuclear force contributes mass defect. And the weak nuclear force is typically also only operative inside the nucleus. But the electromagnetic force would not correspond to a decrease in mass. Gravitational. Well, it's possible they didn't really specify which isotope of hydrogen they're dealing with. I guess you have to infer that there has to be a neutron somewhere. So maybe it's deuterium, which is the one proton, one neutron isotope. So I'd still go for strong nuclear, which is not the force between the proton and the electron, but rather you have to infer that there has to be some neutrons within the atom that contributes to a strong nuclear force. And that would indeed cause a mass defect. But then they say the mass of the proton and the electron is larger than the mass of the atom. If there's a neutron present, then it should not really exceed the mass of the atom. So I don't know, but I may want to come back to this. I said I was going to come back to a question within biology, and I end up not coming back. But I do definitely want to come back here because I want to nail this paper myself. That's stressful. 23, let's move on for now. Feynman diagram is either A or D, and I want to rule D already because you need two particles to coincide with each other in space, which is the vertical dimension. And it cannot be B because you need the electron and the antiparticle to have oppositely running arrows. And D just means that you have an anti-electron, where you have a positron emitting EM wave and then remaining as a positron as a result. Let's just move on. That's straightforward. 24, burning 1 liter of gasoline produces more energy than burning 1 kilogram of coal. What can be deduced from this information? That's confusing. So how do you convert? So this quantity implies that gasoline has a higher energy density. Well, but then, this is some unit mismatch. So liter versus kilogram. So let's say so gasoline is annoying. So this is X joules per cm cube, and this is Y joules per kg, which converted into a liter. And the density of gasoline is less than 1 G. So joules per liter divided by kg per liter. This is density. That's a unit for density, and that's how you get the specific energy of the same substance. And if you divide by a number smaller than 1, then that result will be bigger. So if X is already bigger than Y, then the specific energy of gas should be even bigger than Y, bigger by Y by an even larger amount. So the answer should be specific energy is greater, but when energy density is greater, I guess we don't quite know the density of coal. But I think B is definitely something that we can claim. 25, which change produces a larger percent increase in the maximum theoretical power output of the turbine? So the power equation is in the formula book, and I guess this one is obscure enough, so if you don't remember it. Oh, no. This. No, V cube, and then the R can be introduced as to convert A into pi r squared, because that's usually the circular area swept up by 1 full revolution of a turbine blade. So clearly doubling, like playing around with the speed of the fluid, which is like the wind, will affect the power output of the wind turbine the most. 26 was correct for tangential acceleration of a simple pendulum at small amplitudes. Tangential acceleration should, okay, let's see. But they're only asking you to relate to displacement. It should be proportional and opposite to displacement. So that's just basic addition. Yeah, acceleration equals to negative omega squared x. A is the, not the centripetal, A is the tangential acceleration. So D. Okay. 27 is a diagram shows the diffraction pattern of light passing through a single slit. Wavelength of the slit versus width of the slit. Oh, that's annoying. But it's not too annoying, I guess. It's annoying for me because I haven't done this in a while. Angle equals to lambda over b is the equation for single slit diffraction. And this is for first minimum. So this would be 1 equals to wavelength divided by, I got trapped. It's actually 1 times 10 to the negative 2. I just write 0.01. Equals to lambda divided by slit width. And well, that's exactly what this is. I guess it's just a matter of recognizing what feature to look at, like from the diffraction profile. That's weird. 28 light is centered on the diffraction grating. The wavelength lines are just resolved at the second order spectrum. How many slits of the diffraction grating lines are illuminated? Okay, you have to use the resolvency equation, I'm guessing. This one I must confess I don't remember. It's such an obscure. There is an equation in the formula book, so I'll just use my notes. Do I have access to notes on the exam? Well, clearly no. Okay, but the equation in the formula book, but I don't want to consult the formula book because I don't know what to click. I don't know why I store my formula book on my computer, but this is the equation. Lambda over delta lambda equals to mn. And m is the order and n is the number of slits illuminated. So I need to open all my windows again. That's awkward. Okay, but anyways, there we go. There we go. The lambda can just be, it's not going to make a too big of a difference whether you use 600 or 601.5. And with the nice numbers within the choices, I'll just use 600. And then delta lambda is just 1.5. Units are the same, so no need to worry about. M is a number of order. Well, M is an order, and which is 2 in this case, and n is the number of slits of the grating illuminated. So if we just divide the 2 over, so 600 divided by 3 is 200. 29. Oh, interesting. A train decelerates and then continue to decelerate. Okay, the bridge diagram shows a variation with time. Okay, this situation actually outlined my notes exactly and never come up before. Okay, so I'm proud. Without showing you the notes, I'll solve the question first. Decelerating at a constant rate, well, the frequency at first should be higher, and you should have a decreasing frequency that's higher than the normal frequency. And then shortly after the train passes, the train will be departing. So the frequency drops drastically at the moment when the train passes the person. And because the train further decelerates, the difference between the normal frequency and the perceived frequency will further decrease. So the answer should be D. And I'll show you the answer by the end because I need to just click too many things. Otherwise, 30 is charges. Is it charges? Yeah, electrostatic fields. What's correct about the motion of the particle from X to Y and the magnitude of the work done by the field on the particle. Okay, motion of the particle from X to Y. How does it get there? Right, moves from X to Y due to a uniform electrostatic field, which will definitely cause acceleration. So you can say the acceleration is uniform, but the most likely it will equal some kind of projectile motion. The magnitude of the work done, meanwhile, unlikely is going to be 0 joules, because the electric field means that, well, being present in an electric field means that the particle will experience electric force. So you just do this times the difference. So it's going to be 1 joule. Okay, question 31. What is the correct unit for gravitational potential? You just need to know this. It's joules per kg, and if you split joules into the standard SI unit, joules is kg m squared s minus 2. And the kg cancel with the per kg within gravitational potential. So answer is A. 32, a planet has r, the escape speed is v, and then at what distance from the surface of the planet is the orbital speed? 0.5 feet. That's confusing, because you have to use a couple of equations. V ask equals to 2gm over r, and I think this is in the formula book. And then v orb, I think v orb is also it. Okay, so v orb at the surface would equal to 1/√2 times v ask. Which is 1/2 v, the v given in this question. This is annoying. So you want 0.5 v over if you orbit at the surface, then we're looking at an orbital speed of 1/√2 v equal to gm over r, and then gm over r nu, which is what we're trying to find. A whole bunch of stuff cancels. So r over r nu, if you deal with all this, so that's half over 1/√2. The left-hand side cleans up to be 1/√2 itself. You square both sides, I think you have 1/2 equals to r over r nu. So r nu equals to 2r. That's annoying. I hope it's correct. Conductor ring encloses that area and perpendicular to the magnetic field of that direction of magnetic field is reversed. Okay. So average EMF induced over this is interesting. So V EMF, they used epsilon for EMF, but I'll just use epsilon maybe, equals to BA over T. But they changed, strictly speaking. And you have to use standard units. So 2, the area is 2. The change in B is 5 becoming -5. So it's minus, well, there should be an extra negative outside, but it rarely matters. -5 minus 5. That's times 10 to the -3 times 2 times 10 to the -4 all over 4. So this is something to do with 10 times 2 divided by 4. So it should end up with a 5. So without actually working out the powers of 10, I think D is the correct answer. Answer should be D. Question 34 is just conservation of energy. I think that's what you have to recognize. I would say more like conservation of energy is consistent with Lenz's law, because you can explain Lenz's law in terms of force instead of in terms of energy instead. Anyways, a resistor designed for use in a DC circuit is labeled that the resistor is connected in series with an AC of peak potential. Okay, that's interesting. Because average power supply can equal to IRMS VRMS. Okay. So the DC current, I'm not sure what this is used for. The 2 ohm should be useful. Because P equal to I, let's deal with this first. P equal to I squared R and P equals to V squared over R. I'm guessing the rating label indicates that the normal voltage is indeed 10. And then the working current would be 5, I think. And here you have a peak potential of 10. So assuming that the resistance stays constant, you can use P average equals to VRMS squared over R as well. The peak potential difference is 10. So VRMS itself is 10 over root 2 because the factor of root 2 is how you convert peak potential to RMS potential for a sinusoidal supply. So P average would equal to 10 over root 2 all squared and divided by 2. So that's 100 over 2 over 2, so 25. Uh, 36 capacitor is connected to a power supply, and then so standard discharging of a capacitor, the variation of charge. Oh, that's very annoying. Because you've got Q equal to Q0 E negative time over RC. And then you have charge equals to voltage times capacitance itself. So the charge would just be Q equals to V naught C. The C is a constant, so all this. So most likely you need to look at this. RXT, no, that's how things work. Should just be D. Okay, 37, what's the consequence of uncertainty principle? Uncertainty principle, there's position momentum. The product of the uncertainty need to exceed some constant. And nothing to do with A. I want to say B. Low energy states have short lifetimes. Well, these definitely correct. A is usually the energy of the transition that has to do with the lifetimes and not just the energy state. Electrons cannot exist within the nucleus. I want to say, so within the nucleus, like something to do with position momentum, maybe. If the position is just too well known, then the momentum is unknown. I don't think this has to do with uncertainty principle per se. But electrons in low energy states have short lifetimes. Sounds more consistent with energy type, but then I'm not sure why it's low and low. From my experience in chemistry spectroscopy, I think so some transitions have long lifetimes and some transitions have low, but then it's quite like dependent on the type of spectroscopy. But I'll just go for B, but I'll try to think about this after the exam because this video is dragging on too long. like A's hydrogen spectrum discrete. It's just an observation that that's from the emission, like from the emission spectrum or absorption spectrum. But photons have no mass. But photons have momentum for sure. But that's something to do with something to do between uncertainty principle and photon, but I don't think momentum is one of them. I mean, photons do not have momentum is even the correct statement. Let me come back to this, but let's move on for now. Okay. Photoelectric effects. Okay. Showing different beams of light incident on X, Y, and Z. Okay, so you can tell which beam of light has higher photon energy and which beam of light has more electrons, or more photon. Okay, X requires a high stopping potential, so X definitely has high frequency. You can see Y and Z have the same frequency because they have the same stopping potential here. Different intensity for sure, because you get different sizes of saturation, or different sizes of the current when there's no voltage. More intensity means more photon, means that more electrons can be released during the photoelectric effect. But one is definitely wrong, so answer should be 2 and 3. Okay, decay constant. So the relationship between decay constant and half-life, lambda equals to ln 2 over t half, and that's, I'm not sure whether that's the equation actually in the formula book. I want to say no. But what's the half-life for these samples? So 0.7, 0.35-ish. So 1 second. So half-life is 1 second. So the decay constant is, yeah, half-life clearly 1 second. Lambda equal to ln 2 divided by 1. So are you guys supposed to know the value of ln 2 with a calculator? I mean, it's 0.693. I guess it's A. What's the reason for postulated existence of neutrinos? The reason that people knew that neutrinos thought that neutrino exists is because of beta energy of emitted beta particles at a continuum spectrum. And I'll just show you the notes here. I'll show you the Doppler thingy first. So I had the accelerating train. So the green graph is the expected frequency. For the perceived frequency should be like when the train is accelerating. I can actually resize my window like this. Okay, never mind. Though I don't need to click back and forth. The beta particle experiment. That's actually tested a lot in past paper multiple choices. I'll just show you the answer. I'll just show you my notes, which is in. Somewhere in here. So a 3-particle fission involving neutrinos and or antineutrinos being emitted and traveling at random directions is postulated to explain the many possible energy content of the beta particles, as there are many ways for beta particles to like share momentum and energy with the daughter nuclei as well as the neutrino. So that's why the answer is D. The ln 2 thing, let's check it out as well. Because I think in my notes I said what the equations are in the formula book and what the equations are not. So T1 half equals to ln 2 over lambda. This important equation is not provided within the formula book, so I guess it's something that you just need to know. Should we go back to question 22 with the hydrogen atom? The sum of the mass of the proton and the electron is larger than the mass of the atom. So I don't think there can be any neutron involved. Can it be just the gravitational force because of the natural masses of the protons and electrons? Maybe is it the weak nuclear force? I'll just rule out the wrong answers because electromagnetic, I don't think has anything to do with the masses. Strong nuclear, if there's no neutrons and electrons are irrelevant when we consider strong nuclear forces. Okay, I'll change to C again. Hopefully it's correct. And then this one I'll just leave as such. All right, let's check the answers. Okay, D, C, C, D, that's all good. B, B, A, D, B, I dodged this bullet. A, oh, I got 12 wrong. That's not cool. Hey, I got this one wrong for some reason. I didn't even doubt myself. What's going on? Maybe I should. Okay. B, okay, this one, oh, it's actually neither A or B. Electromagnetic force causes some off effect. Okay. So I got 3 wrong. That's so many wrong. Okay. A, B, D, D, A, C, D, the rest is good. A, I'm going under law. And then this is the debatable one. Well, that's a lot wrong. Some of the wrong ones I discussed during the paper, so I'm not going to rediscuss them, but let's just figure out what I got wrong. I got this one wrong for some reason. Oh, I just choose it. I definitely said the right thing. And I even said it's common sense. I definitely said the right thing, so but I created an answer wrong, so okay, whatever. Okay, it is what it is. Okay. 18. Current carrying solenoid, the velocity of the electron is parallel to the solenoid's axis. The electron is. They say it's not undeflected. Slow down. The velocity of the electron, so why would it slow down? Well, I guess the electron generates its own magnetic field. Is it about electromagnetic induction? Because the electron's magnetic field may interact with the magnetic field generated by the solenoid itself. I mean, the solenoid may have some of these inductor effects, but I don't think induction is actually, inductance is not part of the syllabus. I don't remember my inductance from uni. So what's the velocity of the electron parallel to the solenoid axis causes it to slow down? Would it experience an electric field? They didn't specify the direction of the current, and that's why I never brought up current when I analyzed the question. This is like the first time when I don't understand why I made a mistake. Let's save it for a different video. Question 22, I got this one. This is electromagnetic force that causes a mass defect. I need to check my notes because I don't know this. Never seen it in past paper either. I got 32 wrong for some reason. Did I not analyze it correctly? Okay, let's do this properly again. This is not something that I should get wrong. So you have V equals to root 2 GM over. Let's just, maybe I just misassign some of the rows of the V's, and that's very annoying. just let's just do v squared equal to 2 gm over r. So the radius equals to, should I do radius? I want to do v, I want to compare the v orbs, because v orb is gm over r. I see it. Okay. It's a math studies mistake. Okay. And well, guess what? I made a math studies mistake. Okay. No, the calculation is perfectly fine. It's the answer B first. Let me check my answer B. Okay. Yes, it's answer B. So that's okay. So for those who don't know what a math study mistake is, that's a disgrace to the family. They're asking for the distance from the surface and not distance from the center. So 2r with the distance from the center. So math studies can often overlook the need to subtract the radius of the planet from the orbital radius. Okay, kill myself. Oh, that's so embarrassing. Okay. Anyways, yeah, it's a long video, and the uncertainty principle, I guess I'll just have to, and you guys also need to look at your notes. All right, so I'll try to bounce back with my paper 2 times. No, I mean my time zone 2 multiple choice, which is the last one that I've not done yet. All right, thank you for watching. See you guys next time.